This video is a continuation of the review for our big quiz on trig verifications. And we're on example number 4, and remember, when we're verifying, we're only going to work on one side. And oftentimes, the side to start with is the left side. It's not always the side, but oftentimes it's the left side, and that's where I'm going to start on this particular problem. And when we look at this, the cosecant can be rewritten as 1 divided by sine. And over here we have sine of theta over 1. Well, now that we have a fraction in this problem, let's rewrite it so that we have a common denominator. And so since our denominator is sine of theta and 1, our common denominator is simply sine of theta. The nice part about the common denominator being sine of theta is that for our first fraction, it's going to remain 1 over sine of theta. But what's happening here is that when we're getting a common denominator, we can ask ourselves, well, what did we put into the denominator that wasn't there before? Well, what we put into the denominator that wasn't there before was a sine of theta. In other words, what we're doing is we're multiplying by a fancy form of 1. So we've got sine theta times sine theta divided by sine theta. Don't cancel anything out. Let's rewrite this. And it becomes 1 minus sine squared theta, which, by the way, is what sine theta times sine theta equals, divided by sine of theta. And we're trying to turn this left side into the right side, which is cosine theta cotangent theta. And we're not going to do anything to the right side. Don't touch the right side here. But now what happens is, do we know what 1 minus sine squared equals? 1 minus sine squared theta equals. And if we have to look back at our yellow paper for a moment, but that's something that we need to know for our quiz, but 1 minus sine squared is cosine squared theta. And it's cosine squared theta divided by sine of theta. And now we're getting close here. We need to think about, what does cosine squared equal? Cosine squared theta equals cosine of theta times cosine of theta, and it's all divided by sine theta. So we're getting really close, because what we can do is we can split this apart. We can rewrite this as cosine theta divided by sine of theta times cosine of theta divided by 1. Notice, when we're multiplying fractions, we multiply the tops together and the bottoms together. So cosine times cosine on the top will give us the cosine squared. Sine times 1 will give us sine on the bottom. And what happens is, when we rewrite this expression, cosine divided by sine turns into cotangent of theta. We don't do anything with the cosine of theta, because as we look once again on the other side, you can see it on your paper, I can't see it on mine, but we have, on the other side, we have cosine theta cotangent of theta. And I know they're in different orders on both sides, but the cotangent on the left side is the same as the cotangent on the right side. And the cosine on the left side is the same as the cosine on the right side. Number 5. Again, pick the most difficult side to turn into, and so we're picking the harder side, which is probably the left side once again. And one of the things, first of all, that I see in this problem is that we have a tangent, we have a cosine, we have a secant. One of our best techniques for helping us to solve these, or to verify these, is to turn everything into sines and cosines. So let's rewrite this problem, first of all, in terms of sines and cosines. Tangent squared is sine squared theta divided by cosine squared theta. Don't forget the square. And then that's going to be times cosine of theta over 1. And that's what's in the top of the fraction. Down here in the bottom, 2 times secant theta is the same thing as 2 times 1 over cosine theta. So there's the secant theta with the reciprocal identity. So we can simplify that a little bit more here. And this is sine squared theta times cosine of theta. We multiply the tops together. We're multiplying the bottoms together. And then down here in the denominator, we have 2 divided by cosine of theta. Well, we're going to simplify a little bit more. I know I tend to write out an extra step. I have no issue with that. But sine squared theta, cosine theta, and down here in the denominator, cosine squared can be rewritten as cosine times cosine. That's the top of that fraction. We still have the 2 divided by cosine of theta. Well, what I'm looking at specifically is the very, very top of this complex fraction, but what we see is that we've got a cosine of theta and a cosine of theta. And ultimately then, when we simplify this, now what we have is we have sine squared theta divided by cosine of theta divided by 2 over cosine of theta. But let's go old school here. If you watched any of the videos before, you hear me say old school. Let's rewrite it as sine squared theta divided by cosine of theta, and then we're dividing by 2 over cosine of theta. And when dividing, don't ask why, flip the second one and multiply. So we get sine squared theta over cosine of theta times cosine of theta divided by 2. And we've already had to do it once in this problem. When we multiply here, we're going to multiply the tops together, and we're going to multiply the bottoms together. When we multiply those together, what we end up with is we end up with sine squared theta cosine theta. I'm going to write my number out here in front, the 2 first. We tend to like to have the number out front. We have 2 cosine theta. Well, what we see now, we can ask ourselves, do we have anything exactly the same on the top and on the bottom? And we see that we've got a cosine for both of those. So what we end up with here now is we end up with sine squared theta over 2, which does happen to be the same as the other side of the equation. But if that's confusing to you, what you can do is you can rewrite it like this. The number in front of the sine squared is 1. So this is 1/2, if we take the number and we write it out in front, times sine squared theta. And again, when you compare it to the other side says 1/2 sine squared theta. I'm going to pull back up here to the beginning just to make sure here. But yes. So sine squared theta divided by 2 is the same value as 1/2 times sine squared theta. But if you want to be really specific there, you can rewrite it so that you see that. Problem number 6. I'm going to start with the right side in this particular problem. One of the techniques that we've talked about when we're doing verifications is if we have something plus or minus 1, and specifically on the yellow paper it says if you have sine plus or minus 1 or cosine plus or minus 1 as part of a fraction, you can multiply by the conjugate. I'm going to take this term over here on the right side and I'm going to multiply it by the conjugate. And the conjugate says that you change one sign. So I'm going to multiply it by cosecant of theta minus 1. The thing is, if we're multiplying the bottom by cosecant theta minus 1, then we need to multiply the top by cosecant theta minus 1. We're multiplying by a fancy form of 1. And what I'm going to recommend, once again, is when we multiply these, I'm going to write it down here. I'm going to leave cotangent of theta times cosecant of theta minus 1. I'm not going to multiply those out yet. If we need to multiply out later, we can. But I'm not going to multiply out yet. I'm going to spend my time here for a couple minutes multiplying cosecant of theta plus 1 times cosecant of theta minus 1. And that's the double distributive property, or the FOIL, whichever one you may prefer. And we still have the cotangent of theta in the numerator times the cosecant of theta minus 1. But down here in the denominator, cosecant times cosecant. Well, cosecant times cosecant is cosecant squared theta. And it's going to be cosecant times negative 1, which is going to be minus cosecant of theta. Positive 1 times cosecant of theta is positive cosecant of theta. And then positive 1 times negative 1 is negative 1. Now, if you've really been doing your practice, we have done this a fair amount of times enough to know that we've got a negative cosecant theta and a positive cosecant theta in that problem. They're going to cancel out. So that helps maybe a little bit. We still have cotangent of theta times cosecant of theta minus 1. But what we're trying to do when we multiply by the conjugate is we're trying to, we're trying to trying to get a Pythagorean identity. I'll finally get that out. So the question now becomes what does cosecant squared theta minus 1 equal? So if we have to, look back at our yellow paper, but that's something, remember, we're not going to have tomorrow. But as we look at cosecant squared theta minus 1, we find that what that equals, and I'm writing down the numerator again, the top of the fraction. What that equals, cosecant squared theta minus 1 equals cotangent squared theta. Once again, I always like to write out an extra step because for some people fractions seem to be quite difficult for us. I'm not going to change any value in the numerator here, and I'm not changing anything for that matter. But cotangent squared. Squared means times itself. This is cotangent theta times cotangent theta. And when we get to this point, what we're asking ourselves is, do we have anything exactly the same on the top and the bottom? And what we see here is that we see that we've got a cotangent in the numerator and a cotangent in the denominator. So when we simplify that, we've got cosecant of, got to write it correct, cosecant of theta times 1 divided by cotangent of theta. And let's check and see what's on the other side of our equation. And sure enough, cosecant of theta minus 1 over cotangent. Cosecant of theta minus 1. Oh my gosh. Cosecant, CSC, minus 1 divided by cotangent of theta. So if you're watching this video, go back now and study your trigonometric identities reference sheet. You need to know the reciprocal identities, you need to know the quotient identities, and you need to know the Pythagorean identities. We gave you a paper that has 4 places to practice, filling in all of those. That's how you're going to start your quiz tomorrow. Remember, it's worth 50 points, and it's going to be our last big grade of the quarter. Good luck with your studying.